Okay, so now we want to graph an exponential function. Now, the value of x could be anything, any real number, so that's the domain. But we'll make a table of values to kind of see what's going on here. So let me make a table of values here. X and f of x. Okay. If I put in like -2, then what I get is f of -2 is going to equal 4 to the power of -2. Well, what do negative exponents do? Reciprocal, right? So that's going to be 1 over 4 squared, which is 1/16. Okay, and we can graph, 1/16. We can graph that point, -2, and that's going to be just a little bit, it is positive, a little above the x-axis there. All right, what if we put in -1? Then we have f of -1, which is equal to 4 to the power of -1, which is equal to 1 over 4. So a little bit bigger, 1/4. It's going up. It's kind of hard to see because this is pretty small scale here. All right, what if we put in 0? Well, f of 0 would equal 4 to the power of 0, and anything to the 0 power is 1. So we get the point 0, 1. What if we put in 1? Well, f of 1 is going to equal 4 to the first power, which is going to be 4. 1, 2, 3, 4, so they're right there. And what if we put in 2? Well, then we have f of 2, which is equal to 4 squared, which is going to be 16. And that's kind of off my charts already, so it's like up here someplace. And that's what we mean about it growing exponentially. It goes up really quickly. Okay, so the way the graph comes, it's going up really fast, and then it's going small as the values of x get smaller and smaller. It starts to run, almost parallel. It's approaching, we say it's approaching the x-axis, okay? So it's not going to hit the x-axis. There's nothing I can put in that gets me an output of 0. And I can't put in an x value that's going to make it negative because my base is positive. So that's the way the graph looks. Okay?